Hello everyone, welcome to today's video. So I've come with a very exciting problem today. So I would say it's the problem of medium level of difficulty, because the only part where we actually need to think upon is and to find the logic is to find the value of f of x, and from then all all the other properties of f of x that I actually need to find will become actually that's also a easy part. That's a very easy part, so we don't need to bother about it. So only part we need to understand and need to think upon is to find the value of x. So this is all the same pattern of the last problem that I have taken in this series. So I'm actually taking in the way consecutive videos would be of medium to hard difficulty level, and the other two consecutive videos will be above hard level to tough level. So in this way I'm actually taking the pattern of the problems. So I hope you guys will understand that. So coming to this problem, so the problem is an even polynomial function f of x satisfies a relation f of x into 1 minus f of 1 by 2x plus f of 16x square y is equal to f of minus 2 minus f of 4xy. So this is the equation which is actually satisfied by f of x, and f of 4 is equal to minus 255 and f of 0 is equal to 1. So these are the two values that are given to us. So we need to find the values of a, b, c, d, where a denotes the point of local maximum of f of x and b is greater than or equal to f of x into f of 1 by x. So we need to find the value of b which could satisfy this. It's basically asking the maximum value of which this equation can take, f of x into f, this expression can take f of x into f of 1 by x. And c denotes the range of values of k for which the mod of f of x is equal to k minus 2 as exactly 4 distinct solutions. And so for this f of x, the mod of f of x should be equal to k minus 2, and this k should be taken in such a way that this equation will have 4 distinct solutions, and the d value it is actually asking the range. So c denotes range. Fine, it denotes range, and d denotes the value of 0 to 1 f of x dx. So it's a basic integral, basic definite integral. So once we find the f of x, I hope all these finding all these values of a, b, c, d will be very easy. So starting the solution, first of all let us write the equation that is given to us, that is f of 2x into I'll just write the next I'll just simplify it. F of 2x, I'll just multiply f of 2x that's there in the very first term to the second term, f of 2x into minus f of 2x into f of 1 by 2x plus f of 16x square y is equal to f of minus 2 minus f of 4xy. Fine. So this is the equation given to us. The very important point that we need to keep in keep in consideration is this is an even polynomial function. Fine. What does an even polynomial function say? F of x will be equal to f of minus x. Fine, isn't it? So this is what it says, f of x is equal to f of minus x. So we need to consider this. Now we have this f of minus 2. Fine, we have this f of minus 2, and so this is the only part where we have a negative term in the expression, negative input is being given to us. So what if we change this? What if we have in the place of y, in this term, if we just see this term, if we just have a look at this term, if I just have y is equal to 1 by 8x square. Fine, if I just have y is equal to 1 by 8x square, this comes out to be f of 2, and because it is an even polynomial function, f of 2 will be equal to f of minus 2, so that we can just cancel these both terms. So we need to find such a logic in this way, we need to actually simplify the equations, go on to the next steps. So we need to find a way where we can actually simplify the equation and convert that into a suitable form. Fine, so I'll be doing is I'll be substituting this y is equal to 1 by 8x square, so that I can just cancel these both terms. This is going to be f of 2 and this is f of minus 2, and because f of x is an even polynomial function, so these both are equal, so we can just cancel the terms. So I'll be applying that logic. So when I substitute y is equal to 1 by 8x square, I would get f of 2x minus f of 2x into f of 1 by 2x. So we are not doing any substitution with x, we are just substituting in the place of y. And so the next term that gonna be f of 2, which is equal to f of minus 2, and now we have a y term here once again, so that is 1 by 8x square. So 4x into 1 by 8x square, that is 1 by 2x. So it is minus actually, so minus f of 1 by 2x. So this both terms gets cancelled, and here we have f of 1 by 2x. So we have f of 2x here, f of 2x into f of 1 by 2x, f of 1 by 2x. So if I assume this as a, this is ab, and this is b. So we could just send these terms to the left and right side, so that we could get into a simplified form, because we could say a, b, b. So these are the terms that we have. So once we write it in the simplified manner, so we're gonna get f of 2x. So I'm just gonna send this term to this side, that is f of 1 by 2x will be equal to f of 2x into f of 1 by 2x. Fine. So this is what we have got finally. So this, if I this as assumed as a, so finally we got into it in this form, like a plus b is equal to ab. Fine, this is the form we have got. And now if a functional equation is in this pattern, like if it is in this pattern, that is a plus b is equal to ab, then that means that it is the polynomial, like the f of x should be 1 plus or minus x power n. Fine. So how did I get this? So I'll just explain that with the proof. First of all, the equation that we have is f of 2x plus f of 1 by 2x is equal to f of 2x into f of 1 by 2x. Fine. This is the equation that we have. So what I'll be assuming is, I'll just assuming the z value to be 2x. So this is finally f of z plus f of 1 by z is equal to f of z into f of 1 by z. Fine. So now this, what I'll be doing is, I'll just send this term, like I'll just find the value of f of z. So that is f of z, I'll just send this term to this side. So that becomes 1 minus f of 1 by z, and that is equal to minus f of 1 by z. So f of z would be f of 1 by z divided by f of 1 by z minus 1. So this is the value of f of z. Fine. This is the value of f of z. Now I'll be finding the value of f of 1 by z. F of 1 by z is basically just replacing the z by 1 by z. Fine. If I just replace that by 1 by z, I would get the value to be f of 1 by z is equal to f of z divided by f of z minus 1. So I'll just rearrange the terms. If I rearrange the terms, so this is the second part that I've got, f of 1 by z is equal to f of z by f of z minus 1. So if I just rearrange the parts, so that I'll be getting f of 1 by z minus 1 is equal to f of 1 by z by f of z, and from here I'll be getting f of z minus 1 is equal to f of z divided by f of 1 by z. Fine. This is what I got. So this is from the very first part, this is from the first part, and this is from the second part. And now if I just multiply these two equations, I'm gonna get f of z minus 1 into f of 1 by z minus 1 is equal to 1. Fine, because these both terms are reciprocals of each other, so when multiplied, so they get the product comes out to be 1. So f of z minus 1 into f of 1 minus z 1 by z minus 1 is equal to 1. And if I just assume this as some I'll be using blue ink. So if I assume this some h of z, and like if I assume this as some h of z, like f of z minus 1, if I assume that as h of z, then this will be h of 1 by z, isn't it? So this, if I assume h of z, this would be h of 1 by z, because in the place of z, if I substitute 1 by z, I'll be getting this one, f of 1 by z minus 1. So I've just assumed this as h of z, and this would be h of 1 by z. So that means h of z into h of 1 by z is equal to 1. Fine. So when multiplied, like what type of equation can actually satisfy this, what type of polynomial equation can actually satisfy this? If h of z is equal to some z power n, if f of z is equal to z power n, then h of 1 by z is equal to 1 by z power n, that is this, and when multiplied, this is actually 1. Fine. So that means a polynomial equation in this type, like z power n or 1 by z power n, either it may be positive or negative. Fine. If both are, like, if this is positive, then this will also be positive. If this is negative, then this will also be negative. So both can satisfy, isn't it? So in that case, like, this actually comes out to be like the function which can satisfy is h of z is equal to plus or minus z power n. So this is what it can actually satisfy. And this h of z is actually f of z minus 1, isn't it? H of like, we have taken that consideration. This is f of z minus 1 is equal to plus or minus z power n. So this comes out to be f of z is equal to 1 plus or minus z power n. Fine. So this is the final value. And what's the value of z? Z is nothing but 2x. So finally this equation transforms to be f of 2x is equal to 1 plus or minus 2x whole power n. Fine. So I hope you guys understood this, what is actually being happened here. So this is how we have got the function value, like f of 2x is 1 plus or minus 2x whole power n. So in the place of, like, if I keep 2x, it is 1 plus or minus 2x whole power n. If I just substitute x, then it's gonna be, if I substitute x, then it's gonna be f of x is equal to 1 plus or minus x power n. Fine. So this is the functional equation that is the value, this is the value of f of x. Now all the properties will be very easy, like we just need to find the properties. So the very first part is, like, a denotes the point of local maximum of f of x. So we have found the f of x, like what could be the functional f of x value, but we have not come to the actual f of x. Like, see here, like we have the f of 4 and f of 0 values. So we need to make sure, like, we are finding the like we find a suitable function which can satisfy this. So first of all, f of 4 is equal to minus 255. So we shall do that. So let us take the first case, that is 1 plus x power n. So in the place of x, like f of 4, if I consider plus x power n, okay, if I consider plus x power n, then f of 4 would be 1 plus 4 power n, and this, it is equal to minus 255 as told. So 4 power n is minus 256. And for what value of n can actually 4 power n be minus 256? There can be no value, because if n is equal to 4, then 4 power n is equal to 256 as some meaning. But if for no value of n, we can find f of n like 4 power n to be equal to minus 256. So if I take 1 minus x power n, and then f of 4 is equal to 1 minus 4 power n, which is equal to minus 255. So 4 power n is equal to 256. So the n is equal to 4. So now we are able to find a suitable value, a suitable value for which they satisfy. So the function is 1 minus x power n. That means like the function value is like 1 minus x power n. So this is the value, like n is equal to 4 that we have got, because that is what it satisfies, right? Like f of 4, like f of 4, it's given to be minus 255. So only in this case we'll be getting it. So the value of n is equal to 4. So that means the value of f of x is 1 minus x power 4. Fine. So this is the value. So this is the actual function that we need to consider. So a represents like, what's the a denotes the point of local maximum of f of x. So let us plot the f of x, and we can actually say it. We don't even need to do maximum, minimum, or something like that. We can just plot the equation, plot the graph of f of x, and then we can actually tell it. So like, this is the y-axis, and this is the x-axis. And let me take this. So x power 4 is the equation given to us. So we know that how does it actually look. So we can just like, we can have a shape in this way. If it is, yeah, actually it is minus x power 4, like 1 minus x power 4. I hope you people actually know the graphical transformations. So 1 minus x power 4, like at f of 0, it's 1. So this, it could be 1. So at this point from it, here it originates, and because it's minus x power 4, the coefficient of leading degree of x is minus, so it will be a downwards facing parabola. So from this I can just say the equation could be in somewhat in this way. Fine. Like the graph could be somewhat in this way, like this is the value of 1 minus x power 4. And now from here we can say that this is the local, like the global maxima. Fine. From here we can say the maximum value is 1 at x is equal to 0. Fine. The maximum value is 1 at x is equal to 0, and this is the global maxima. There's no other maxima that exists. So like so in the seeing the graph in the total R plane, so this is the maximum value of the function. So the maximum value of f of x is 1, and that at x is equal to 0. We can even straight away tell that, because the function is f1 minus x power 4, and x power 4 is a like every term, like whatever it may be, negative or positive, it's gonna give you at finally a negative value, like positive value, like 1 minus x power 4. This is always positive, so 1 minus of anything you'll be reducing it. So unless and until if x is equal to 0, there will be no reduction. So finally this will be the maximum value. So at a is equal to, like, it denotes a point of local maxima, so a should be equal to 0. And now b is greater than or equal to f of x into f of 1 by x. So it's again a simple problem. So f of x into f of 1 by x, so that is 1 minus x power 4 into 1 plus 1 minus 1 by x power 4, and that is 1 minus and plus 1 and minus of x power 4 plus 1 by x power 4. So you can do am greater than or equal to gm, so that will be 2 minus 2, which is equal to 0. So finally this, the value of this which satisfies us, so 0. So b is equal to 0. And now come to the C part. C part says mod of f of x is equal to k minus 2. So I'll just draw the graph of mod of f of x once again. Like this time mod of f of x, it's not f of x. So mod of x, mod of f of x is basically from here. Fine. So 1 minus x power 4, like when it is 0, actually x power 4 is equal to 1, that is x is equal to plus or minus 1. Fine. So at 1 it is 0, and at minus 1 it is 0, and this is 0 and this is 1. So this is the mod of f of x, like mod of 1, like this is the graph of mod of 1 minus x power 4. I hope you guys know this. Like we just need to take the reflection about x-axis to find the mod of a function. So this is how it looks. So now this is equal to k minus 2. This is equal to k minus 2 has 4 distinct solutions. Now if there is any line in this case, like if there is any line in this case, we can find 4 distinct solutions, isn't it? We can find 4 distinct solutions: number 1, number 2, number 3, number 4. When if this line crosses this part, fine, if the line crosses this part, we cannot find more than 2 solutions. It's not possible. So if this line crosses this line, like this point, then there will be no 4 solutions. There will be only possible 2 solutions, maximum 2 solutions possible. So for this line, like for this equation, like f k minus 2 is equal to f of mod of f of x, to have 4 distinct solutions, it must be like k minus 2 must be between like 0 and k1. Fine. So from 0 to 1, if k minus 2 line, like this is the line of k minus 2, if I assume that's k minus 2 line, like k minus 2 is equal to y, so this to have more 4 distinct solution, it must be between 0 to 1. So 2 is less than like this is the range, like k must belong to 2, 3. If k is equal to 3, then we'll have this to be 1. Fine, this is equal to 1, and if it's 1, that line would be in this way, touching this at here, this at here, and then we'll be having only 3. So to have 4, it must be less than 1 and it should be greater than 0. So the range is 2, 3. Fine, this is the value of c. And coming to the last question, this is very basic question. So integration 0 to 1 minus x power 4 dx, it's x minus x power 5 by 5 from 0 to 1. So that is 1 minus 1 by 5, which is equal to 4 by 5. So the answer for the d is 4 by 5. So I hope you guys like actually enjoyed this session. So it's all about the basic things, basic manipulations, and the logic that we actually need to find the f of x value, and this all the other parts, like finding the point of local maxima, or this value, like where the maximum value of the expression f of x into f of 1 by x. All these are very easy things. Like we don't even need to plot the graph and do all those things. Just analytical thinking, and to find the actual essence of x power 4, if we do that, it's just a very easy thing to find all these properties like a, b, c, d. So I hope you guys actually understood this. So thanks for watching. Stay tuned.